Hey all, I just realized that I did not cover in my last video for connective tissue the bone models. So I wanted to really briefly just kind of walk you through the bone models. I also think these might help you out a little bit with the slides. So we're going to go over the bone models here, again, just in a really short video. And then please go back and look at some of the cross-section slides for compact bone. And I think you'll find that these models will really kind of help you understand what you're looking at there. So if you look here, the first model here is a compact bone osteon, or again, a Haversian system. So again, this is kind of like the basic kind of unit for building compact bone. And so if you look again, it looks like a cross section of a tree. So, and it looks like it's got these annual rings, which you now know are called the lamella. Um, and again, the whole reason that this bone model is built kind of around these osteons is that they have this central canal, and through that central canal is going to be where your blood vessels are going to run. We kind of talked about that, but we didn't talk about the fact that there's lymph vessels as well as nerves running through here. So again, this central canal will have blood vessels, lymph vessels, which I know we haven't talked about the lymphatic system yet, but we will, and then as well as nerves. Okay, so they're all running through that central canal. And we talked about how nutrients will have to move from the central canal, from the blood vessels in the central canal, especially the arteries, right? And bring in nutrients and oxygen through the canaliculi to each of these osteocytes here that are trapped in the lacuna. Okay. So again, I'll go through all of those parts. So here we have the central canal or Haversian canal. You pick which term works best for you. And then here, these concentric rings of matrix that are surrounding that central canal are called the lamella. Okay, so lamella is singular. So this one ring of matrix right here is called the lamella. And then all of the rings of matrix, meaning multiple rings of matrix, this one here, and this one here, so on, are called lamellae. It's just the plural. So again, don't let that confuse you too much. So one ring of matrix, lamella, multiple rings of matrix, lamellae. Okay? So not too bad so far. Again, in kind of basically wrapping around on the outskirts of each of these lamella, you're going to find the lacuna, which are the spaces in which the osteocytes, the bone cells, are kind of trapped in, right? We talked about that. So here you can see if we remove the osteocytes, then all you're left with, which obviously you're not doing in the bone, but basically, if you could do that, all you'd be left with is the space there where the osteocyte was. And that space is called the lacuna, okay? On a practical, we will make sure to ask you what is the name of this space, okay? And that would be lacuna. Now, if we said, what is the name of the cell within this space, then you would say osteocyte, okay? So the osteocyte is the cell within that space. Now, remember we talked about to get nutrients, okay, because this matrix is this nice, hard, dense matrix, right, that makes up bone. So we have to be able to get nutrients to these osteocytes because these osteocytes are living cells. So to get nutrients and oxygen, and then also to bring wastes back, right? We're going to do that through these little cellular extensions, and then there's little canals in which those cellular extensions run, called the canaliculi. Okay, so here you can see they drew in the canaliculi here. So, and here's canaliculi as well. You can kind of see the grooves or the canals. So where those cellular extensions would run. So those are the canaliculi. So again, nutrients would move from this canaliculi, right? into this osteocyte, and then it would be shared from this osteocyte through these canaliculi to this one, and then from here through these canaliculi to this osteocyte, and so on. And that's how the nutrients get to these outer osteocytes. Now, this is also why it limits us in how many rings we can have, I should say lamellae, right, that we can have around one central canal, because you can't get too far out, because about here you're having to share the nutrients all the way from here through all of these canaliculi and all these osteocytes. So that's why, again, we only have so many rings, and then it's just too far out, and we need to have another whole osteon over here. Okay, so hopefully that helps you kind of understand that. So let me go ahead and go on to the next bone model here. So this is kind of a very large bone model. So this was zoomed in really on one osteon. So here you can see these multiple osteons. And like we talked about, again, you can only share nutrients so far, and then you need to have another osteon. Okay, so that's why you can see here, this would be a cross section like through basically a bone. So let's say this was one of your long bones, okay, here. And if you were taking that cross section, here would be the very inside of your long bone where the bone marrow would be. And then here the compact bone would go all the way around, right? This would be if you were doing like a cross section through one of these long bones. And so here you can see on the very outside of that bone, surrounding that bone, is going to be the periosteum. And then here you're going to have, we haven't talked about this term yet, and this is why I wanted to make sure we did bone models. We have what are called the interstitial lamellae. So these are going to be kind of your rings of matrix here that are going to be between the periosteum and then the osteons here. So you will have this interstitial lamellae, and that interstitial lamellae will again get most of its nutrients from the blood through that periosteum, from that periosteum, and then into the interstitial lamellae. Excuse me. So again, this would be, you'll see the interstitial lamellae really on these cross sections where you have like a cross section of like an entire bone, okay? And so then we'll have these osteons, okay? And these osteons are going to have what are called the concentric lamellae, because they're going to be surrounding a central canal, okay? So just so you know the difference between interstitial, because you'll see those terms, interstitial lamellae and concentric lamellae. The concentric lamellae are going to be the rings of matrix in an osteon around, again, the central canal, where interstitial lamellae will be this kind of matrix that the rings, sorry, and I shouldn't say rings of matrix. It technically is one big ring, if you can picture, oops, sorry about that, guys. If you could picture these, let me, sorry, go back to the bone models here if I can get back. But if you can try to, again, keep it, sorry, I ended up on the Zoom. Let's see, reset Zoom here. Let me go ahead and just, I'm on the Zoom. So sorry about that, guys. Let me go ahead and do that. My own technical issues here. Let's get off of that. Oh, here, let me exit here. There we go. And now this should get us back to where we, unfortunately, my menu right there, my menu toolbar is right next to that. There we go. Okay. So again, here, if you look, technically this interstitial lamellae would go all the way around, because again, this is a cross section of a big, again, cross section through a big bone. And this would be the center of the bone where you would find your bone marrow in a long bone. Okay. So hopefully that makes sense. If you have any trouble with that, please feel free to contact me and I can help you out with that if you are having trouble visualizing that. And then again, we go back to the osteons here. So the osteons here in the heart of the compact bone, again, are going to have the central canal. We'll have the concentric rings of lamellae that are surrounding that central canal. Within those lamellae, you'll see that you have the lacuna with the osteocytes within them. And then you have all of these little tiny lines here that make up what are called the canaliculi. Okay. And then just to kind of help you out more so with lecture, we don't really look at spongy bone in the lab. But once we get to lecture, we'll talk about the spongy bone, which would be in the middle, in the kind of center of your long bones, where they would surround this kind of open lumen in the inside that is going to have your red marrow in it, your bone marrow inside. So you would actually have this inner layer here called the endosteum. Again, not as important for lab, but we will get into that in lecture. So kind of the outer layer of the compact bone is the periosteum, and then the kind of inner layer, if you could picture again, this is the kind of like an open, not an open canal because you have spongy bone in there, and that's going to hold your red marrow, but that would be in the very center of your long bones, kind of like the squishy center of your long bones, if you want to think of that way. So hopefully that will kind of help you out with that bone model. So let's get you on to another look at this. So you can see this very large bone model. You can look at it from top down, and then you can also look at it, because again, this is a 3D model, from the side here, kind of looking into that cross section. Excuse me, I'm still getting over a cold here. And so then you can see this periosteum on the outside. You can see some of these osteons sticking up, right? But what's nice here is you can see the blood vessels that would be running through. These are the central canals, okay? And then again, you'd have these concentric lamellae. It's hard. I would never tag it here. You can't picture them going around these central canals, right? That's why we have the top-down image. But you can see all these central canals that are running, and you may have thought, like, well, how do the central canals, like, where are they connecting in from, right? Like, how are they getting all their blood flow into these central canals? So you actually have these Volkmann's canals that run across these osteons. So these are canals running from osteon to osteon, connecting blood flow, again, from this kind of central area here where the red marrow is, all the way through these osteons connecting each central canal. So here's a central canal, here's a central canal, here's a central canal. And then here, the ones running across these osteons are called the Volkmann's canals. Okay? It's just named after the scientist. So that's kind of a one you just have to kind of learn the scientist's name. So those are, I believe, let me make sure that there's not any other bone. I don't think there's any other bone model ones here. I think that's it. Yep, those are the 3 bone models. So again, short and sweet. If you have any questions, please make sure that you contact me if you're confused on any of this histology stuff. I'm more than happy to set up some time with you. That's it.